Welcome to Scale Model Workshop. In this episode of the Airbrush series, I want to go over some tips that might be helpful for airbrush operation. So I'll be taking a look at workspace, air supply, paint, and using the airbrush. Before you start spraying material into the air, we need to give some thought about all the material that doesn't wind up on the model or on the paper around the model. The rule of thumb's pretty simple. If you can smell it, then it's in the air. So it's important to control the aerosolized material to maintain a clean and healthy workspace. If you're working in a closed environment, you definitely need some sort of spray booth that exhausts the material to the outside. In addition, if you also want to ensure that you're not inhaling the material, invest in a good respirator mask. And if you're using solvents like I do, this isn't an option, along with nitrile gloves to keep the solvent off your skin. Airbrushing literally begins with air, so you need a good reliable source. Depending on your needs, there are three basic options: some form of compressed air tank, a diaphragm or an on-demand compressor, or a tank compressor. The compressed air tank works well in a limited environment, especially where noise is an issue. But if you use a lot of air, you might find refilling the tank inconvenient. Diaphragm compressors are common among airbrush users. These compressors run continuously while painting because they have no tank to store the air. They have the advantage of being relatively small and economical, but their CFM output's fairly limited. The most robust and versatile air supply is the tank-type compressors. These store the compressed air in a tank, so they cycle on and off, maintaining a specific pressure in the tank. This gives them the advantage of a smooth supply of air at a greater CFM, giving you the capability to operate any airbrush or miniature spray gun. All compressors heat the air as it's compressed. As the air cools on its way to the airbrush, there's condensation in the tank and air lines. In addition, if the compressor uses oil, there's more than likely some oil in the tank as well, so you should have a moisture trap and filter located close to the airbrush. Having a moisture trap at the compressor will have limited effect because there'll still be condensation in the air line. Finally, you need a regulator to adjust the air pressure. It doesn't have to be elaborate, and both the filter and regulator can be easily adapted to any system. If you're using a tank compressor, when you've finished painting, bleed the tank and leave the valve open. You want to avoid leaving the tank full of air and condensation for extended periods. It's also a good idea to put a little thought into making your air painting as easy and convenient as possible. Quick connect fittings make attaching hoses and airbrushes very easy. If you frequently use multiple airbrushes, you can build your own manifold from stock plumbing components. In my case, I built this manifold so I could just take the air from my large shop compressor. And if you have multiple air outlets, think about adding an air nozzle for blowing off parts at the last minute or when you're cleaning your airbrush. One of the most common questions asked is, what pressure should I be spraying at? Well, unfortunately, there's no magic number. First of all, the number you see on a regulator attached to the tank has little relevance to the actual number at the airbrush. The actual pressure into an airbrush or spray gun is measured at the inlet with full airflow and no material flow. This is easy enough to measure and regulate with a miniature spray gun, because you can easily attach a gun gauge to the inlet, but this doesn't work for an airbrush. Pressure from the compressor varies with the length and diameter of the hose, and especially with the inside diameter of the fittings. If you look at the path the air takes as it gets to your airbrush, you can see the effect on pressure and air volume as it encounters a restriction from a fitting. There's an increase in pressure when encountering a restriction, and as the air passes through the fitting, the air pressure drops and the volume of the air has decreased. So when you set up your system, you want to be aware of the variations that will occur in airflow as it passes through every fitting, disconnect, or filter. These variations in volume are important if you're using a miniature HVLP spray gun, and it's the reason you should use larger diameter hoses and fittings when using one. So two different systems could easily have different pressures at the airbrush, even though they both have 20 pounds at the tank. But practically speaking, the only time pressure is critical is when you're using an HVLP spray gun. So even though the number isn't absolute, it's fine for a reference with your particular setup, which is all we really need for an airbrush. Don't become a prisoner of someone else's number. But okay, Captain OCD, you're not happy with such flippant disregard for a specific number. You've managed to attach a gauge from the U.S. Bureau of Precise Air Pressure Regulation directly to your airbrush, and figured out that the exact optimum pressure for spraying phthalo blue through your Olympus Micromagnesia 2100 is 17.5 pounds. But hold on, Captain. Other than negating the effect of the lightning holes in the trigger, you've actually added zero relevant information to the equation, because the most important measure of proper airflow is the amount and velocity of the air passing over the needle, and in the real world, every airbrusher gun has a different design, different internal architecture, and the viscosity and weight of the materials vary significantly. So even though you now have an exact read on your inlet pressure, you still don't know what's coming out of the air cap. That's why with HVLP spray guns, where air pressure is critical, it's verified with a cap gauge. So after all this, you can see that we might be able to discuss air pressures in a general range, but in practical terms, the actual resulting spray pattern and surface finish are what's important, and for that, we need to look at the other half of the equation, how you handle the material. How much should I thin my paint? Well, it's a common question. It really isn't that simple, and it deserves a better explanation than a vague reference to dairy products. Because many times, it isn't just how much you're reducing the paint, but it's also what you're reducing it with. So you need to have a real understanding of the material you're using. 40 years ago, it was a lot simpler. We basically only had two types of paint, lacquer and enamel. Now we have a myriad of different materials, and most have an acrylic component. So before you get out your chemistry set, I strongly suggest that you start with what the manufacturer supplies or recommends. Because we use such small amounts of paint, much of how we handle the material comes down to feel and experience. I suggest that you audition a number of the paints that are out there. Just get a color or two and play with them. See what you think and what you like. See how they perform for you. Once you've settled on a particular brand or line of paint, stick with it and learn how to really handle it. If they don't have the color you want, learn how to mix it. I think you'll have a whole lot more success in the long run, and you'll get a better feel for how much to reduce it, or if you need to add a retarder to slow the drying time. Once you've got the air and paint situation sorted out, you need to get comfortable with using the airbrush, and there's no substitute for practice. Different situations require different techniques. If you're painting freehand camouflage, you're working in close with low air pressure and material flow, and you need to get a feel for keeping the airflow going and triggering the amount of material. If you're putting down a gloss finish, you need to get a feel for even overlapping strokes that maintain a wet coat. Or working into corners so you don't get a lot of buildup from bounce back and fog. These are just a few examples. Every situation's different, but the more you do, the more comfortable you'll get, and the more information you'll have in your playbook, and the less surprises you'll have. As always, I hope this video has been helpful. So long for now, and I'll see you next time.